Welcome back, guys. This is going to be a review question for the exam you're going to be taking. This covers kinematics in one dimension and going from a graph to a different graph. So it says a student stands in an elevator and records its acceleration as a function of time. The data are shown in the graph above. At time t equals 0, the elevator is displacement 0 with the velocity of 0. Assume that the positive direction for displacement, velocity, and acceleration are upward. Determine the velocity v of the elevator at the end of each 5-second interval. All right, so for the first 5 seconds, my acceleration is 0 and my velocity is 0. So my velocity is going to stay there. For the next 5 seconds, my acceleration is 4. My initial velocity is 0. So I would use v equals v naught plus at. And so I would have 0 plus 4 times 5 would give me 20. For the next 5 seconds, my acceleration is 0. My velocity is going to stay the same. And for the final 5 seconds, my acceleration is negative 4. So I'm going to have v equals v naught plus at. I start at 20. I have negative 4, and 5 seconds gives me 0. All right, I'm going to pause this because I'm going to erase this because I want to scroll and this stuff will stay in place. I want to scroll. All right, so I'm going to put these back in now that I'm here. So I said this was 0, 20, 20, and 0. Plot the velocity as a function of time on the following graph. So our velocity stayed at 0 for the first 5 seconds. It ended up at 20 from 5 to 10 seconds. So this would be a straight line, the slope of which would be positive 4, because that was my acceleration. From 10 to 15, it stayed there, and then from 15 to 20, it went back down. Determine the displacement of the elevator above the starting point at the end of each 5-second interval. All right, so to start with, I wasn't moving, I didn't have acceleration, I don't have displacement. 5 to 10 seconds, I'm going to find the area. So I'm going to have 1/2 5 seconds times 20 meters per second. So 5 times 20 would be 100, divided by 2 would be 50. From 10 to 15 seconds, it's going to be this rectangle that has a base of 5 and a velocity of 20. So I've gone an additional 100 meters. So I would add that to the 50. And now I'm 150 meters away. And then 15 to 20 is going to be another 50 meters because it's the same triangle, just the mirror of it. So now I'm at 200 meters. All right, I'm going to erase this because this will stay in place as I scroll. And I'm going to write it back in. So I had 0, 50, 150, and 200. So what is this going to look like? My displacement is going to go from 0 to 50 over this 5-second interval. It accelerated. It had a positive acceleration of 4. So I would expect this, because on a displacement time graph, acceleration is a curve. Then it's going to go from 50 to 150 in the next 5 seconds. This would be a straight line. The slope is going to be the constant velocity of 20. And then finally, I'm going to slow down. So I have a deceleration from 150 to 200. My final slope should be a horizontal line. So I'm going to curve it and there. So that's what my displacement would look like. And I want my slope there to be close to 0. All right, I'm going to erase this again and scroll. Well, that's the end of that one.